Hello M3, this is Teacher Bean and welcome to part 7 of chemical reactions. Make sure to watch the previous videos about chemical reactions. For this video, we are going to learn how to balance equations. So let's review first the word chemical reaction. So a chemical reaction is a change that takes place when one or more substances form one or more new substances. So in a chemical reaction, it's something like 1 plus 1 equals 2, wherein your 1 plus 1 there is your reactants, and your answer 2 there is your products. So to show the equation, it goes like this. So you have your reactants is equals to your products. So always please take note of the arrow. So the arrow always points to your product. So like for example, 1 plus 1 is equals to 2. So let's try to view more examples of your reactants to products. So our reactants here, so we have the elements carbon and oxygen. So if these two combines, so you will have your product, which is your carbon dioxide. Now let's learn this next word equation. So what is a word equation? So it uses the names of your reactants and your products to show what will happen to your chemical reaction. So like for example here, so we have your sulfur, which is being burned in your oxygen gas in order to make your white solid called your sulfur dioxide. So using your word equation, which is your reaction to product, so we can have this your sulfur plus oxygen. These are your reactants. And your product here is your sulfur dioxide. So this is what you call your word equation. Our next term is your state symbol. State symbols. So what are state symbols? So these are like letters that you are adding into your equation, whether it is a reactant or a product. So like for example, so we have here for solid, the symbol is S, liquid is L, gas is G, and dissolved in water, you have your AQ. AQ meaning aqueous. So, like for example, so using your sulfur and oxygen to make your sulfur dioxide. So this S here inside this bracket, it means solid. The G here inside your bracket is your gas. And again, still the same, G here is your gas. So sulfur, which is solid, combine with your oxygen, which is gas, to make or to react or to make your sulfur dioxide, which is a gas. That is your state symbol. And finally, before going to balance our equation, so we have here your law of conservation of mass. So this law of conservation of mass states that the mass is neither created nor destroyed in any chemical reaction. So everything is balanced. So let's try to look at our examples here. So in our example, carbon and oxygen here, to produce or to make your carbon dioxide, so you have to make sure that the number of atoms in reactants, meaning your carbon and oxygen here, must be equal to the number of atoms in your product. So like for example, in your reactant, you have one carbon. So therefore, in your product, you also have one carbon. In your reactants, you have your two oxygen. So therefore, in your product, you also have two oxygens there. So meaning this word equation is balance because you have one oxygen on both sides, one carbon on both sides, and two oxygens in your both sides. Okay, about your balancing equation, this is more of like math wherein you have to try and do some experiment in order to get it balanced. So, like for example, you have here your Mg plus O2 to produce your MgO. So, using our learning about ionic and covalent bonding, so let's try to name this one first. So, Mg is what? Metal or non-metal? So, Mg is a metal. And O2 here is your non-metal. So, we are forming a what? an ionic compound or ionic bond. So meaning, so how do we name this one? MgO. Okay, this is you name it as your magnesium oxide. So this is magnesium oxide. Okay, so in your magnesium oxide here, so looking at the equation, so we have here one magnesium this side in your reactant. There are also two oxygen on in your reactant side. In your product side, there's one magnesium and one oxygen. So looking at it, you can say that this is not balanced, right? Because you have two oxygen on the reactant, you only have one oxygen in your product. So the first thing you're going to do is to write the elements that can be found on the reactant side and write also the elements that you can found in your product side. So just like this one. So this arrow here will separate the reactant and your product. So you have here MgNO for the reactant, MgNO for the product. Now, the next thing to do is to write the number of atoms. How many atoms in your reactant side for magnesium? Okay, magnesium has one only atom. How about oxygen here? This is 2. How about on the product? How many magnesiums are here? So there are only 1. And how many oxygens are here? There are also 1. So looking at here, this is not balanced because one magnesium and one magnesium is already okay. But it does not mean that magnesium is already stable. We have to look at also the other elements. So therefore, let's do the experiment. Again, when you do balancing equations, you cannot change this one. Again, you cannot change the number here. If this is 2, then this will be 2. It's fixed, it's permanent. Please do not change it into 1 just to make it balanced. Okay, so our only solution here is to go up. To go up, 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 and up. So meaning let's add big numbers. So in order to make this balance, so let's do an experiment here. So instead of adding or making it 1, you have to look at also the reactant and the product at the same time. So if my product or if my reactant has 2 oxygen, so maybe I can have this oxygen in the product side to have maybe 2. Okay? Now, if you look at your product here, you have your MgO. If you add oxygen, if you make oxygen here 2, then therefore your magnesium will also become 2. Okay? Because your MgO in math is something like this. It's like an A plus B. And if you add 2 here in front, so distributive property, so something like this, it will become 2A plus 2B. So meaning, if I add 2 oxygen here, if O is B here and Mg is A, so if I add 2 oxygen here, therefore my magnesium will also become 2. So meaning, this one will not be 1 and this one will become 2. Right? Now, 1 magnesium versus 2 magnesium. So my equation now is not balanced. So magnesium is not balanced anymore because I added 2 on your product side of magnesium. So to make it balanced, so I will just change this one into 2. So how do I write this equation now, teacher? Because this one now is balanced. 2 Mg and 2 Mg balanced. 2 oxygen on the reactant and 2 oxygen on the product is also balanced. So your equation is now balanced. So therefore, your final answer can be written this way. So it means 2 magnesium plus 2 oxygen here to produce 2 magnesium oxide here. Okay? Let's try to check more examples of your balancing equation. So before revealing the answers of these balancing equations, so I want you to get a paper and try to solve it by yourself. Okay, so let's have your first example. So NaCl is what? This is your sodium chloride. So your sodium chloride is an example of your ionic bond. So if you haven't watched the video, please watch ionic bond video. So first rule is we have to write the elements here. So you have your NaCl squared to produce or to make your sodium chloride here. So sodium and chlorine on this side, sodium also and chlorine on this side. So next thing, we have to write the numbers. So the coefficient, we call it as your coefficient. Coefficient is the number that is in front of your element. So how many sodiums are here? Only one. How many chlorine? There are two. On this product side, how many sodium? There's only one. And your chlorine is also one. Looking at it, so there's two chlorine and one chlorine on the other side. So again, we cannot change this one. So but however, we can adjust the coefficient. So meaning we can change this one. Maybe let's adjust it into 2. Now, if I make chlorine 2, so I have to change also the sodium into 2. So what happens is that your sodium on the reactant and sodium in your product is not balanced. So we have to adjust this one and change it into 2. So 2 sodium check. 2 chlorine and 2 chlorine check. So therefore your final answer will be 2 Na plus Cl2 is equals to, or to produce your 2 NaCl. So this will be your final answer. Next, let's try to look at our next example. We have your CH4 plus O2 to produce CO2 plus H2O, which is your water. So your CH4 is an example of a hydrocarbon. So CH4 is a methane. So this one is methane. So burn to your oxygen to produce your carbon dioxide and your water, or your H2O. So how do we balance this equation? So this one is a bit longer, but we can do this one. So first thing to do is we have to write again, or rewrite the word equation, CO2 plus H2O. So breaking it up, so on the reactant side, we have carbon, hydrogen, and oxygen. And your product, we also have your carbon, hydrogen, and oxygen. So let's write the numbers. How many carbon? There's only one carbon. How many hydrogen? There's 4. How many oxygen? There's 2. On your product side, how many carbon? There's only 1. How many hydrogen? There are 2. How many oxygen? 2 plus 1 is equals 3. So you can pause this video to think of the correct answer. Okay, let's check your answers. So again, this is a trial and error. So if you look at the equation here, so it looks difficult, but actually it's simple. So from your elements here, CHO, carbon, hydrogen, oxygen, so which element do you think we have to adjust? Okay, so let's do some experiment here. So like for example, I have 2 oxygen here and 3 oxygens here. So what if I make it like 6, or maybe I'll make it 4? So here's my advice, M3. You start first with the lowest number until you go higher and higher and higher. Okay? So 2 oxygen here and 3 oxygen here. What if I make it have it like this? Instead of using have 2, I'll make it 4 oxygen. And instead of using 3 here, I'll have it 4. Okay? Now, if I adjust oxygen into 4, so meaning I have to add 2 more oxygen in your product equation. So which side should I use, the CO2 or the H2O? So I think we can adjust here with your H2O. So if I add 2 here, so your hydrogen will become 4 without affecting your carbon here. So I think this is now the final answer. So in writing this one, so we can have it this way. So we have here CH4 plus Oxygen is 2, right? So this we can write here 2, O2, to produce your CO2 plus 2 here. Okay, so this is the balance equation. So if you look at here, we have 1 carbon, 4 hydrogen, and 4 oxygen. 2 times 2 equals 4. 1 carbon, 4 hydrogen, 2 times 2 equals 4. We also have 4 oxygen here because 2 oxygen plus 2 oxygen, so this is 4. So therefore, this is our balance equation, CH4 plus 2O2 to produce CO2 plus 2H2O. Now let's have your third example. We have here your lithium plus your nitric acid. So your NO3 here is your nitrate. If you add an H in front, so this is a symbol of your acid. So this is a nitric acid to produce your lithium nitrate and hydrogen. So we are going to write first the equation, Li plus Li is your lithium plus your nitric acid to produce your lithium nitrate and your hydrogen. So again, let's write first the elements, Li, H, N, O, and then Li, N, O, and H. Next, let's write the coefficient. How many lithium? 1. How many hydrogen? 1. How many nitrogen? 1. How many oxygen? 3. How many lithium? 1. How many hydrogen? 2. How many nitrogen? 1. How many oxygen? 3. So, you can pause this video to think of the correct answer to balance the equation. Okay, so when you're ready, so let's begin. So if you look at it here, lithium, nitrogen, and oxygen, they are already balanced. So the problem here is your hydrogen. So if we change hydrogen, so let's adjust this one. So hydrogen becomes 2 on this side. So hydrogen is now balanced. Now if you go back here with the equation, remember that hydrogen is bond with your nitrogen and oxygen. So if I change, or if I make hydrogen here too, so therefore my nitrogen will also be affected, right? So the nitrogen on the other side will also be affected. Okay, going back. If I add here, or if I change hydrogen into 2, nitrogen into 2, so meaning I add here a coefficient of 2, right? So if I add here a coefficient of 2, so 3 times 2, it will become 6. So your oxygen here will become 6. And if oxygen on the reactant is 6, so possibly the product will also be having 6. So let's now look at the equation. So lithium is only, what do you think? Is it 1? Okay, so please look at here. So I will make this oxygen into 6. So meaning I have to add a coefficient of 2. So meaning if I add here 2 here, so the lithium will also be affected. So it will become 2. So the other side will also become 2. So let's try to check. So 2 lithium, check. 2 hydrogen on both sides, check. 2 nitrogen and 6 oxygen. So let's write now your equation. So there will be 2 lithium to combine with your 2 hydrogen, 2 nitrogen, and 6 oxygen to produce your 2 lithium, 2 nitrogen, 6 oxygen, plus your hydrogen. So this one is your final answer. Okay, and finally, so we have here your example number 4. We have your aluminum plus your oxygen to produce aluminum oxide. So let's rewrite again the equation. So aluminum plus oxygen to produce your aluminum oxide. So let's break it down. So I have here aluminum and oxygen here. Aluminum and oxygen here. Let's write the coefficient. So aluminum has 1 atom, oxygen has 2 here, then the other side, your product side, so you have 2 aluminum here and 3 oxygen here. So I want you to pause the video to think of the correct answer to balance the equation. Okay, so when you're ready, let's begin. So if you look at it here, all elements here are not balanced, right? So in here, this is not balanced, so this one is also not balanced. So the possibility of changing the numbers are big. So let's start first with your oxygen. So you can just do like this. So 3 times 2, you'll have your 6. So we can adjust this one into 6 and 6. So if I add 3 here, so 3 times 2, I'll get 6. So if I have here like 3, so to get 6, I have to multiply it by 2, right? So if I will have it 6 for oxygen and I add 2 in this compound, so 2 times 2, this will become also 4. So therefore, if I have 4 aluminum on this side, so this one will also be adjusted and to have 4. So therefore, my final answer will be, let me just erase this one to finalize the answer. So there will be 4 aluminum combined with your 6 oxygen gases. So instead of writing 6, we just have to write 3. 3 times 2 is equals to 6 to produce, okay, 4 aluminum. So we have here 2 times 2 is equals to 4. Then 3 times 2 is equals to 6 oxygen atoms. So this is my final answer. So please do the worksheet. And once you're done, please upload the file in your Google Classroom. So once again, M3, thank you very much for watching and have a nice day. Thank you and goodbye.